Hey, what's up, guys? We're talking about proportional relationships, being able to look at a relationship in a graph, a table, equation. Is it proportional or is it something else? Okay, so these are the main things to look for when you're trying to decide it. So equations show a multiplicative relationship. That's just a fancy way of saying multiplication. Okay, our equation is going to be y always equals something times x. And we're going to find out what that something is, but y equals something times x. That's what we're looking for in equations. Y equals something times x. When we're talking about graphs, they have to be linear. And linear just means straight line. Okay, so if you don't know that word, good place to write that down. Linear means straight line. And it always has to pass through the origin, which is at 0, 0. Okay, it always has to go through there. And that is what is called the y-intercept. And we're going to get more into that as we go through the unit. But where a graph crosses the y-axis is called the y-intercept. So that's your brief introduction to that new vocabulary. Where a graph crosses the y-axis. Okay, so our graphs, two things have to be true. Equations, it has to be y equals something times x. And then we finally have our tables here. And with our tables, it has to have this constant ratio, okay? Y divided by x. And we're going to look at what all those means because that's a lot of words. So let's look at what is proportional, and then we'll look at what's not. What you need to know here is the graph, table, and equations that we're looking at are separate stories. They don't represent the same thing, okay? The graph is its own thing, the table's its own thing, and our equations are their own thing. So I don't want to cause confusion with you like, wait, how's that table the graph? They're not related, okay? All right, so with graphs, a proportional relationship has to be linear. So I'm looking at the shape. This is a straight line, so it's linear. And it has to pass through the origin. This passes through the origin. That's why this shows me it's proportional, okay? It passes through the origin and is linear. That's all we're looking for just to be able to tell if it's proportional. Then we look for other relationships, but right now that's all I need there, okay? In a table, I'm looking for the constant ratio. So y divided by x has to be the same everywhere in my table. And so I'm like, well, what do you mean y and x? Remember, in our tables, x is the left, y is the right side. I'm going to skip this row. This is the origin right here. Remember, tables show me ordered pairs. That's the origin. So I'm going to skip that row and I'm going to look right here. 6 divided by 2 equals 3. 12 divided by 4 equals 3. 18 divided by 6 equals 3. Hey, they're all the same. This is a constant ratio. They're all the same. That's what that means. That's what we're looking for. Everywhere I divide y by x should be the same number. If that's not true, it's not proportional. Okay? The other thing now with equations, so we looked at graphs, linear and through the origin, tables, a constant ratio, and then with equations, it's this multiplicative relationship. So it just has y equals something times x. This one is 5 times x, okay? There's nothing else part of it. That's it, 5 times x, right? Same thing with this equation. It's y equals, and this time that something is 2/3 times x. That's how you know it's proportional, okay? So let's look at, well, if that's what proportional looks like, then what does it not look like? All right, so start with the graph. It has to be linear and go through the origin. So this one is linear, but it doesn't pass through the origin. That is not the origin, okay? So that means it's not proportional. It's a different kind of relationship, but not proportional. When I look at my table, the constant ratio y divided by x, right? So labeling all my pieces, I'm going to skip where x is 0, okay? This tells me my y-intercept, where it crosses the y-axis. We'll get more into that, okay? I'm going to go each row. 10 divided by 2, y divided by x, right? That equals 5. 16 divided by 4, that equals 4. 22 divided by 6, that equals 11 over 3. That's not proportional. Not the same ratio. Okay, as soon as you see that, as soon as you see any of it's different, it cannot be a proportional relationship. All the numbers have to be the same for it to be proportional. And then finally, our equations. The big clue here is as soon as you have any additional amount, okay, because proportional is just multiplication. So as soon as you throw in an extra amount, that is no longer proportional. That's our big takeaway. So we want to know, can I identify proportional compared to non-proportional in graphs, tables, and equations?